Next question. Given that A and B are two matrices such that A into B is equal to A, B into A is equal to B, then to prove that A square is equal to A or A is idempotent matrix. Okay. Given that A into B is equal to A and B into A is equal to B, then A square is equal to A into A. Again, given that A is equal to A into B, A into B, by putting A is equal to A into B in equation 1, so that A square is equal to value of A is equal to A into B into A. We know that by associative property of matrices, property of matrices, A into B into C is equal to A into B into C, so that A square is equal to A into B into A. And again, given that B into A is equal to B, then A square is equal to A into B into A. The value of B into A is equal to B. Again, the value of A into B, A into B is equal to A, so that A square is equal to value of A into B is equal to A, means that A square is equal to A, means that A is idempotent. Matrix. Okay, I am repeating. Given that AB is equal to A and BA is equal to B, then A square is equal to A into A. This is equation 1. Given that A is equal to A into B, then by putting the value of A is equal to A into B, so that A is equal to A into B, so that A square is equal to value of A into B into A, so that by associative property of matrices, A into B into C is equal to A into B into C. This becomes A into B into A, so that again given B into A is equal to B. By putting the value of B into A is equal to B, this is equal to A square is equal to B into A. Again B into A is equal to A, so that A square is equal to A. Means that A is any idempotent matrices. Next question. Question number 2. If M is any matrix of order 3 cross 3 which satisfy the following equation n into 0 1 0 is equal to minus 1 2 3 n into 1 minus 1 0 is equal to 1 1 minus 1 and n into 1 1 1 is equal to 0 0 12. Then find the trace of M matrix. I am repeating the given question. If M is any square matrix with the order 3 cross 3 which satisfy the following equation: M into 1 M into 0 1 0 is equal to minus 1 2 3, M into 1 minus 1 0 is equal to 1 1 minus 1, M into 1 1 1 is equal to 0 0 12. Then what is the trace of matrix M? Suppose that M is equal to x1 y1 z1 x2 y2 z2 x3 y3 z3. Then we want to calculate the trace of M, means is equal to x1 plus y2 plus z3 is equal to question mark. Okay, the question is what is the trace of this matrix, or what is the sum of x1 plus y2 plus z3. Now n into 0 1 0 x1 y1 z1 x2 y2 z2 x3 y3 z3 into 0 1 0 is equal to minus 1 2 and 3. Okay, by equation number first, so that by metric multiplication horizontal and vertical, means that 0x1 plus y1 plus 0z1 means that this into this, 0 into x1 plus this into this, 0 into y1 plus 1 into y1 plus z1 into 0. Similarly, this into this means that 0x2 plus 1 into y2 plus 0 into z2, this into this plus this into this plus this into this. Okay, similarly this into this plus this into this plus this into this, means that 0 into x3 plus 1 into y3 plus 0 into z3. Okay, now this into this. Next, okay, is equal to minus 1 2 3. so that this is y1, this is 0, this is 0 y1, this is 0, this is y2, this becomes 0 y2, similarly y3 is equal to minus 1, 2 and 3, so that by comparing y1 is equal to minus 1, y2 is equal to 2 and y3 is equal to 3. I am putting the value of m. This is x1, y1, z1, x2, y2, z2, x3, y3 and z3. Means that y1, y2 and y3 is equal to minus 1, 2 and 3. Next, again given that n into 1 minus 1 into 0 is equal to 1, 1 and minus 1, means that the value of m x1, y1, z1, x2, y2, z2, x3, y3 and z3 into 1 minus 1 and 0 is equal to 1, 1 and minus 1, so that I am multiply by 1 minus 1 0 to m, horizontal and vertical, taking row with column, this into this plus this into this plus this into this, means that 1 into x1 minus 1 into y1 plus 0 into z1. Similarly, this into this means 1 into x2 plus minus 1 into y2 plus 0 into z2. Similarly, horizontal and vertical means that 1 into x3 plus minus 1 into y3 plus 0 into z3 is equal to 1, 1 and minus 1, so that this becomes x1 minus y1, this is x2 minus y2, similarly x3 minus y3 is equal to 1, 1 and minus 1. Next, by comparing x1 minus y1 is equal to 1, putting the value of y1 is equal to minus 1 in equation 1. I am repeating, putting the value of y1 is equal to minus 1 in this equation, so that x1 minus value of y1 is equal to minus 1. Value of y1 is equal to minus 1 is equal to 1, so that x1 plus 1 is equal to 1, means x1 is equal to 1 minus 1, x1 is equal to 0. Similarly, x2 minus y2 is equal to 1. Equation number 2, putting the value of y2 which is equal to 2, means that x2 minus value of y2 is equal to 2 is equal to 1. By solving this equation, x2 is equal to 1 plus 2, so that x2 is equal to 1 plus 2 is equal to 3. Similarly, x3 minus y3 is equal to minus 1, and the value of y3 is equal to 3, so that x3 minus value of y3 is equal to 3 is equal to minus 1, so that x3 is equal to minus 1 plus 3, x3 is equal to 2. Okay. means that this is the value of x1, this is the value of x2, and this is the value of x3. So that x1 is equal to 0, x2 is equal to 3, and x3 is equal to 2. Next, m into this is equal to 0, 0, 12. M into 1, 1, 1 is equal to 0, 0 and 12. Means that the value of m, x1, y1, z1, x2, y2, z2, x3, y3 and z3 into 1, 1 and 1 is equal to 0, 0 and 12. By calculation, horizontal and vertical means that this into this plus this into this plus this into this means that x1 into 1 means x1 plus this into this y1 plus this into this z1. Similarly, horizontal multiply with vertical becomes x2 plus y2 plus z2, last x3 plus y3 plus z3 given by 0, 0 and 12. By comparing x1 plus y1 plus z1 is equal to 0, so that by putting the value of x1 is equal to 0 plus putting the value of y1 is equal to minus 1 plus z1 is equal to 0, 0 minus 1 plus z1 is equal to 0 means z1 is equal to 1. Okay. Next, x2 plus y2 plus z2, x2 plus y2 plus z2 is equal to 0, so that value of x2 is equal to 3 plus value of y2 is equal to 2 plus z2 is equal to 3, 5 plus z2 is equal to 0, so that z2 is equal to minus 5. This is second. Similarly, x3 plus y3 plus z3, x3 plus y3 plus z3 is equal to 12. Value of x3 2 plus value of y3 3 plus value of z3 same is equal to 12. 5 plus z3 is equal to 12, so that z3 is equal to 12 minus 5, z3 is equal to 7. Okay, means that z1 is equal to 1, z2 is equal to minus 5, z3 is equal to 7. Now m becomes m is equal to x1 y1 z1, x2 y2 z2, x3 y3 and z3, so that m is equal to value of x1 x2 and x3 0 3 2, 0 3 and 2, y1 y2 y3 minus 1 2 3. Okay. Similarly, z1 1 minus 5 and 7, so that find the trace of m. We know that trace of m matrix is equal to sum of diagonal element means that trace of m is equal to sum of diagonal element 0 plus diagonal element 2 plus diagonal element 7 is equal to 0 plus 9 is equal to 9, so that trace of m is equal to 9 is correct answer. Okay, next question. Question 3. Suppose that M is a matrix of order 3 cross 3 and N is a other matrix of order 3 cross 3 such that Mn is equal to Nm and M naught is equal to N square, but N square is equal to N power 4, then find out the determinant of m square plus mn square. Okay, I am repeating the question. Given that M is a matrix of 3 cross 3 order, N is other matrix with the order 3 cross 3, such that Mn is equal to Nm and M naught is equal to N square, but M square is equal to N to the power 4, then find out the value of the determinant of M square plus Mn square. Given that M naught is equal to N square and M square is equal to N with power 4, so that M square minus N power 4 is equal to 0. We know that A square minus B square is equal to A plus B and A minus B. By using this formula, M complete square minus N square complete square is equal to 0. By using this formula means that M minus N square, M plus N square is equal to 0. Again, given that M naught is equal to N square, means that given that M naught is equal to N square, so that in equation 1 M minus N square naught is equal to 0 implies that M naught is equal to N square. Again, M plus N square is equal to 0. This is the product of any two non-zero quantity, so that at least one of them will be equal to 0. And in given question, M naught is equal to N square, so that this matrix will not becomes to 0, but M plus N square is equal to 0. Again, we know that if A into B is equal to 0, but A square not is equal to 0, then and determinant of B is equal to 0, then A and B always invertible matrix. then A and B are invertible matrix. I am repeating, if A into B is equal to 0 but A square not is equal to 0 and determinant of B is equal to 0, then A and B are invertible. So that multiplying both sides with matrix M, this become M into M plus N square is equal to M into 0, means that M square minus M N square is equal to 0 matrix, with non-zero matrix is always 0 matrix. Taking determinant both side, determinant of M square minus M into N square is equal to determinant of 0 matrix, and determinant of 0 matrix is always 0 because 0 0 0 0, this is a 0 matrix. Suppose that this is equal to A, determinant of A is equal to 0 minus 0 means 0. So that determinant of M square minus M into N square is equal to 0. This is answer. Question number next.